Hi everyone, exams are just around the corner. I know. But hey, why fear when we're here to make it all clear? We're going to dive deep into atoms and molecules. So let's get started and crack this chemical code together. So let's just start with a really big question. Think about it. What is everything really made of? Your phone, the air you're breathing, even you. If you could just keep breaking it down into smaller and smaller pieces, what would you be left with at the very end? This question has been on people's minds for literally thousands of years.
And the journey to find this answer didn't start in some fancy high-tech lab. Nope. It began a long time ago with philosophers just thinking, just wondering about the world around them. Let's take a quick look at how this incredible idea came to be.
Okay, so this is like a super fast race through time. It all kicks off way back in India around 600 BC with Maharishi Kanad. He came up with this concept of paramanu, the ultimate tiniest particle of any substance or padarth that you just couldn't divide any further. A couple of hundred years later, over in Greece, Democritus had a similar idea and called it atomos, which pretty much means the same thing, indivisible. For centuries, it was just an idea, a thought, until the late 1700s, when a guy named Antoine Lavoisier started doing actual experiments, which then paved the way for John Dalton to give us the first real scientific theory of the atom.
Right, so that big jump from just an idea to actual science, we have Antoine Lavoisier to thank for that. He was the one who said, okay, let's stop just guessing and start measuring. And from his work, he gave us two golden rules that are basically the foundation for all of modern chemistry.
So rule number one is actually super simple, but it's incredibly powerful. It's the law of conservation of mass. All it says is that in any chemical reaction, you can't lose stuff. The total weight or mass of everything you start with has to be the exact same total mass you finish with. Nothing just vanishes into thin air.
And this line right here says it all. Mass can neither be created nor destroyed in a chemical reaction. You can't just create matter out of nowhere, and you can't make it disappear. It's like such a mitra, a true friend. It's always there, it's constant, it never changes.
Let's look at a really easy example to see this in action. Say you take 12 grams of carbon and you burn it with 32 grams of oxygen. What do you get? Exactly 44 grams of carbon dioxide. Look at the math. It's simple addition. 12 plus 32 is 44. The total mass on the left side is exactly equal to the total mass on the right. A perfect balance.
And now for golden rule number 2. This one is called the law of constant proportions. What it means is that any pure chemical compound, let's take water for example, always has the same recipe. It doesn't matter if you get your water from a river, from rain, or from a tap, the elements inside are always mixed in the exact same fixed ratio by mass.
And for water, that magic recipe, that fixed ratio, is always 1:8. For every 1 gram of hydrogen, you need exactly 8 grams of oxygen to make water. Always. No exceptions. If that ratio is different, well, you've got something, but it's not water. The recipe is constant.
Okay, so now we have these two fantastic laws. But what do they really mean? This is where John Dalton comes into the picture. He was the genius who connected these laws back to that ancient idea of atoms and created the first proper scientific rulebook for how they work. So here are the key points from his rulebook. First, he said everything is made of atoms. Simple enough. Second, he said these atoms are like tiny, solid, unbreakable balls. See how that explains the law of conservation of mass? If you can't create or destroy the atoms, you can't create or destroy mass. He also said that all atoms of one element, like gold, are identical, but they're different from the atoms of another element, like silver. And here's the kicker. He said they combine in simple, whole number ratios. And that
That perfectly explains the law of constant proportions. See how it all fits together?
But hey, science is always learning, always upgrading. Dalton's theory was a brilliant start, an absolute game changer. But we later found out a few things. Turns out, atoms aren't indivisible. You can actually break them down into even smaller things: protons, neutrons, and electrons. We also found that not all atoms of an element are perfect clones. We have things called isotopes, like carbon-12 and carbon-14. They're both carbon, but they have slightly different weights. And, to make it even more interesting, we found isobars, atoms of completely different elements that can have the same mass. So yeah, Dalton's theory had a little moi-moi moment, but it laid the foundation for everything we know today.
Okay, we've covered the history. We've covered the rules. Now for the really fun part. Let's use all this knowledge to do something super practical, something powerful. We are going to learn how to write chemical formulas. This is like learning to speak the secret language of chemistry.
So to crack this code, you need one crucial piece of information: valency. Just think of valency as an atom's combining power. It's kind of like how many hands an atom has to hold on to other atoms. Some have one hand, some have two. You get the idea. This number is the key to everything. And here is a super easy trick to use that key. It's called the crisscross method. And trust me, it's as simple as it sounds. Let's try magnesium chloride. Step 1, write the symbols, Mg and Cl. Step 2, write their valencies right below them. That's 2 for Mg and 1 for Cl. Now for the magic. Step 3, you just crisscross those numbers. The 2 from magnesium becomes chlorine's number, and the 1 from chlorine becomes magnesium's. We don't usually write the number 1, so boom. Step 4, you get your final formula, MgCl2. See? Simple.
All right, let's just take a step back and zoom out for a second. We've journeyed from ancient philosophy to the laws of chemistry, and we've even learned to write its language. It all really boils down to one very simple but totally mind-blowing idea.
And that idea is this: the unbelievable, infinite variety of everything in the universe, from a giant star to a tiny insect, is all built from a pretty short list of simple atoms. And they're all just following a handful of simple rules. It's just an unbelievably elegant and beautiful system. Which really just leaves us with one final thought, doesn't it? Isn't it just amazing that a few simple rules can explain every single thing around us? That's the real magic of chemistry. Thanks so much for joining this explainer, and I'll catch you in the next one.